nuclear fusion. Nuclear fission reactors can produce vast amounts of energy from the nuclei of appropriate fuels. The energy output is about 1 million times greater than the energy output through a chemical reaction. Nuclear power is clean. There are no greenhouse gases, so there is no negative impact on air quality or greenhouse gas emissions. But there are problems with storing the waste products. If we look at what would potentially be better than nuclear fission, we arrive at nuclear fusion. Instead of breaking down nuclei to release energy, we will be looking at fusing nuclei together to release energy. So, what is fusion? Protons and neutrons are bound together by a force called the strong nuclear force. Not very imaginative, but a brilliant description nonetheless. By reconfiguring the protons and neutrons into a tighter space, we can release energy. It's that simple. Almost. To make fusion happen efficiently, we need hydrogen, and we need to maintain a temperature of 40 million degrees C. Let's put that into context. The Sun carries out this reaction at 14 million degrees C, and at this temperature it is not that efficient. This is incredible but true. If we were to compare the size of the Sun with a nuclear power station, pound for pound, it produces less energy. So what we need is to create on Earth something more powerful than the Sun in order to get an endless supply of clean, cheap energy. Just think, no greenhouse gases. The fuel could be derived from water, but the bigger problem would be maintaining the temperature of 40 million degrees. This is why scientists are looking at ways of trapping the nuclei using magnetic fields. Earlier on in 2015 we met Jamie Edwards, the youngest person in the world to achieve nuclear fusion. Watch this film as he explains. Jamie Edwards, who is the youngest person to achieve nuclear fusion. Jamie, can you tell us about your project?
Well, what I've done, I've recreated what happens on the Sun, so that's nuclear fusion. So that's when two hydrogen atoms are smashed together to produce helium, lots of energy, and a neutron. We can use this neutron to prove that we've done the fusion, and then we can eventually harness this energy to power towns and cities. So what I've done, I've used this chamber here. We put this down to a vacuum with two vacuum pumps, introduce a tiny bit of deuterium gas. So deuterium is a heavy isotope of hydrogen, so in its nucleus it's got one proton and one neutron. Then we apply a negative high voltage charge to this grid that goes in the chamber here. Just open this up. Then when we apply the negative high voltage to this grid, it ionizes the deuterium that's in the chamber, so it strips away its electrons, so it's leaving just the positively charged nucleus. Then this positively charged nucleus is attracted to the negatively charged high voltage grid. We've got millions all going to the same point. Eventually one will hit the other with a colossal amount of energy, fusing together, producing fusion.